Hello everyone, we're back with another episode of Computer Vision Talks, and today we're going to discuss a CVPR 2022 paper, Spatio-temporal relation modeling for few-shot action recognition by Anirudh. And I'm glad to host Anirudh today because I think he's been attending the talks before, and it's super nice to connect in a way that from being an audience, now we're having a speaker. So over to you, Anirudh. Also, I'd like to give a short introduction first. So Anirudh is an incoming master's student at University of California, Riverside. He finished his bachelor's from Nadar University and has been working as a research assistant at IIIT-Hyderabad as well as MBZUAI. Okay, over to you, Anirudh. Please continue.
Okay. Thanks for the introduction. So I'll present my work, Spatio-temporal relational modeling for few-shot action recognition. This was a work that I performed as an intern at MBZUAI, which is a newly established research organization in UAE under the supervision of Dr. Sanat Narayan, Dr. Salman Khan, Dr. Fahad Khan, Dr. Rao Anwar. And yeah, so I'll just start by giving a brief introduction to the problem of few-shot action recognition. So few-shot action recognition is the application of few-shot learning to the challenging computer vision problem of action recognition. And the task here is to classify an unlabeled query video into one of the action categories in the support set that has a limited number of samples per action class. So the current few-shot approaches have some issues that are like they only search for either the single support video or only the average representation of the support class. But as we can see that they are only restricted to the frame level representations and they are not exploiting the video sequences for the temporal relationship modeling. So a recent approach that was published in CVPR 2021, the temporal relational cross transformers, TRX, it is performing part-based temporal relationship modeling by comparing subsequences of query and support videos. And it is representing the subsequences with different cardinalities for modeling the higher order temporal relations. So I'll just explain it a bit. So yeah, so this is the image that I got from the TRX paper. So as you can see here, the temporally ordered subsequences from the query set that is in the top part of the image are compared against all the pairs in the support set. So if you have like 7 or 8 frames from the query video, and similarly in the support set, then you have like 8 into 7 combinations of it was equal to 56 combinations of pairs that are being compared in the support set. So yeah, so definitely it improved above the previous approaches, but still it is also struggling on the action relevant cues. And that is because it is only utilizing the temporal contextual information and not utilizing the spatio-temporal information during the temporal modeling. So for example, like you can see in the image here, in the example given here, the action regions are not emphasized in the 5th and 6th frame in the B category, which is the pretending to put something behind something from the egocentric SSV2 dataset. And the background region is emphasized incorrectly in the 3rd and 6th frame in the action class category run that is from the HMTB dataset. So these are like 2 different datasets, and still TRX is like failing when you like try to scale it up a bit. So our proposed STRM method, it is enhancing the class specific feature discriminability, and it is mitigating the flexibility issue. So for example, in TRX, like the comparison was against 2 different like a pair of images, and you can scale it up a bit. But as you go for like comparing for like a tuple of 3 frames and like a tuple of 4 frames, if you scale like that, it's very difficult and the model becomes computationally infeasible. So yeah, I'll start off with the architecture. So the first part of the architecture is when you have L video frames, it is passed to a backbone feature extractor, which can be any video feature extractor like a ResNet or a vision transformer, and we get D-dimensional frame features. Yes.
Yeah, yeah. There's a question in the chat box.
Oh, sure,
what is the support set here?
Can you go to the problem formulation? This 2 slides back.
Okay, sure, no problem.
Yeah, when you this.
I got it.
The next slide, where you are explaining TRX, support set, and query.
Yeah, I get it. Okay, yeah, so I get it.
So what is query here and what is support set here?
So query is any unlabeled video. Like that's just the formulation used here. So query is any unlabeled video for which we don't know which particular this video where it should be kept. So for example, like there are different classes in the SSVideo dataset, like putting something into something, or throwing a ball down, or something like that. So there are like different classes like that, and you have some unlabeled query video, and you want to know which label does the query video belong to. So
basically, you compare a query video with all the support set videos, or a subset of the videos, because there can be a lot of videos in the support set.
Yeah, so we are only comparing against like there are different formulations. So there is like 3-way 5 formulation, which is like we're comparing against 3 classes, and there can be even more like 5-way 5 short, which is like 5 classes, and 5 short means 5 samples per 5 classes. So like 25 total samples like that.
But
so as you can scale it up
how do we select the support set? How do we know which 5 videos to compare with?
So there is something known as episode-based learning approach, which is being used here. So so there is, the training part, right? Like you sample some videos in a normal training procedure of a neural network. So like that thing. So here we don't use that formulation because like the samples are very less and you cannot like train like that. So we use something known as episode-based formulation, where episode is just like, you can say, like a training iteration, where each episode you have, like, you say, select like 5 classes randomly, and any 5 classes, and then for each 5 classes you get like 5 videos, and from the 5 videos you get like the 8 or like 7 or 9 kind of frames. So that 8 or 9 frames are like set, but these 5 classes change every iteration.
But this is during the training time. This is how FSAR works during training time. How does it work during test time? Then also it compares with the support set, or it simply predicts at that point?
In the testing time, it only is like predicting it. So like I have actually even shared the code, so you can also like look into code later.
Okay. Thank you.
Yeah, sure, no problem. Where was I? Yeah. So yeah, the architecture. So yeah, see, there are L video frames that are passed to the feature extractor, which can be any video feature extractor like a resonate or a vision transformer, and we can get a D-dimensional frame features, which with a spatial resolution of P cross P. And so the idea behind the patch level enrichment is that it will enrich across all the patches across the frames, and by using the self-attention mechanism. And yeah, that's it. So, and then after that, the enriched PLE features, that is the patch level enriched features, are averaged spatially, like across the frame level, and then it is sent to the frame level enrichment module, FLE module, as shown in the image. So yeah, the FLE submodule is also doing a kind of enrichment, which is global enrichment across all the frames. And so it is enriching the frame representations globally, and by encoding the temporal context from different frames, and it outputs a representation E. And then this FLE module, FLE enriched representations, are then fed to the TRM module, which is performing the higher order temporal representations. So as I mentioned in the TRX, like it is also performing a temporal modeling, where it is comparing like a pair of frames from the support set across from the query video, against the all the pairs from the support set. So similarly, TRM is doing a job of the temporal modeling. And another like learning joint loss that is being learned is for the query class similarity, which is when the patch level enriched features are fed to the query class similarity classifier. And this is mechanism to enhance the feature discriminability. So like different classes are learned like further apart. Like, so that's what we want to do here. So we have two losses here, LTRM, so the loss of TRM, and one is the loss of the query class. So we want to learn like a joint modeling kind of thing. So yeah, so this is the takeaway message, is that our STRM is combining the advantages of both local and global, and sample dependent and sample agnostic mechanisms. And we are getting a enhanced spatio-temporal feature representation. And that is what is improving the classifiability, which is improving the performance in general. So here I will just show you how how adding different components of our model enhances the performance. So this is the image that I got. This is the images from the SSV2 dataset. So yeah. As you can see here, like the baseline model in the attention map, it is missing the important object that is the cat, because the category is a bit difficult. So like it is not able to detect that the cat is the main thing. But when you add the PLE patch level enriched mechanism, it is able to encode the spatial context, and you are able to get closer to the exact image that is the cat. And similarly for the other category also, you are able to like slowly move towards the correct object, that is the book here that is being dropped. Yeah. Oh, and again, if you add the FLE module, you can see that there's a slight improvement over the PLE as well. And for example, in the category A, approaching something with the camera, that is the first category A, the context in the 4th and 6th frame that is missed by the PLE is able to be captured by the FLE module's introduction. So yeah, and then finally, when you add the query class classifier, then in the 7th and 8th frame of B, which is the cat dopping something with something, you are able to even capture the attention on the object, which is book. So yeah, like that's how the progressively we have improved. So this is just the state-of-the-art comparison against the TRX and the other works that have come before. So as you can see here, our approach has gained like 3.5% over the TRX module on the very challenging dataset of SSV2. And if you go to the vision transform backbone also, we are getting an improved 3%. And this is just a bit of qualitative results. So we were, so in the given example, this is the query tuple. So the actual, so the actual label is pretending to put something behind something, right? So the green is the query tuple, and the best match by our STRM module is the second support video, which is a better representation as compared to that of the TRM module, which is the baseline model. Yeah, one second. Yeah, one more result. So even here, the baseline TRM model is unable to capture the support tuples for the query, which is marked in red and green. But our STRM module is able to match it better, as you can see, like if you can compare the different frames.
And is it okay if we take a question here from the chat box?
Sure. Yeah.
Spandan is asking, how does this approach gives an intuition of increasing class separability?
Okay. You mean this query class similarity, this one?
Just a minute. Let me ask him to unmute himself if he wants to go ahead and ask the question.
Yeah, hi. So exactly, this is with respect to the query class similarity, where the approach of this entire thing that you described, how does this ensure that there is a support in increasing class separability? Like what intuition does it provide, since we are analyzing both on the spatial domain as well as on a temporal domain?
Yeah. So the query class similarity classifier is only taking the patch level enriched features. So right now the frame level hasn't come in the picture. So what it does is that it is trying to learn like it is trying to like increase the distance between the it's something like it's something similar to the contrastive learning thing, not exactly, where it tries to increase the distance between the images of separate classes, and it tries to decrease the distance between the images of like similar classes. So if you can read the code also, it will be very helpful. And like for example, yeah. So there is one class which is pretending to put something behind something, which has some images, like the video has some images, and you can see the second class can be yeah, like dropping something behind something, dropping something on something. So what it does is the query class. Yeah. So what this query class similarity module does is that it will try to increase the distance of the images between pretend to put something behind something and dropping something on something class, and between the images, within the images of pretending to put something behind something, even if it's a separate video, it will try to decrease the distance between them. So if you read the code, it will be a bit like more easy to understand. And if you can, if you know image matching algorithms, it's similar to that. The intuition is similar to that. That's why we have used here.
And what was the loss metric? I'm sorry, did I miss on it?
Yeah, so it's the joint loss. So like one is the TRM based loss and one is the query class similarity loss. So like a joint learning kind of thing. Yeah.
Okay, I hope that answers your question, Spandan. Okay. Cool. We can continue, I think.
Sure. So yeah, like, so yeah, the code is available here at this particular repository, and this is just the miscellaneous research advice. So like research is very tough, as everyone knows, and like it's very competitive now. So you should get very good mentors and like collaborate with people of like similar interest. And even if the level is not like if the level is same, it's fine, but both should be able to put enough effort. And I understand that it's difficult to find collaborators and like get into research. So best way is to like attend local events like the summer school at IIIT-Hyderabad, summer school at IIT-Kharagpur, or even like just machine learning meetups like this, computer vision talks. So that's a very good way. And even Twitter is a very like Twitter, LinkedIn, a lot of profs keep posting there these days. So you can cold email some profs and ask them if you can collaborate with them. And there are even some amazing initiatives like the ML Collective and Courier for AI, which is a free to entry like organization where anyone can enter, and they will you can collaborate with people of similar interest. And there has been some very good work which is coming out of both ML Collective and Courier from AI. Like there has been a publication in CVPR also. And it was posted on Twitter. So yeah,
I know. I did reach out to him. Sorry. Yeah, I did reach out to him for sharing his experience on how does ML Collective work, and I do have a lot of questions for you regarding that. But first, I think Kunal wants to ask something regarding the paper, so let's take that first.
Sure. Yeah, go ahead.
Okay, Kunal, feel free to unmute yourself.
Okay. Can you go back in the architecture slide? Yeah.
All this one.
Yeah. So there are different frames, right? And the features are extracted per frame level.
Yes.
So is it any ResNet or VIT, but that is being run frame level? How does it represent a video level feature then? Where is this merging of feature happening?
So like first we get the features from at the frame level from the feature extractor. Then it will go through the different layers. So till here it's like till patch level enrichment, like the frames are unaware of the other frames. Like so it's like there's no merging happening. But here the averaging is happening across the frames of the same video. And then in the FLE it is being aware of the other frames. That's what is being done.
Okay. So my question is averaging a good way of merging features together? Averaging, yeah, like this averaging is happening per frame level, I think so. The average that you are taking is per frame level, not across the video.
Yeah, not across the video. Yeah. It's like, so we try different heuristics like like max pooling and all that, but I think averaging worked out well here. And like that's what even I saw in different papers. Like sometimes average pooling works, sometimes max pooling works. So there's no like consensus on what is the best way.
And how does
It depends
PLE
on the
module
problem.
works? Even though it's not your contribution, PLE module was previously done by the paper that the baseline paper.
No,
right?
this PLE is our contribution.
Okay.
It's
okay.
Yeah.
So
PLE is it's based on attention mechanism, like a basic attention mechanism. Yeah, like just a query, there's a query, there's a key, there's a value, like that. So it's a
so what is the role of PLE? What is the exact role of PLE? So this is patch level enrichment, right? So what is the exact role of PLE here? Like, have you done any ablation study of individual
yes,
modules?
Definitely, we have done all that.
Okay. I'll see the paper.
Yeah, sure. Yeah, so PLE, what it does is that, like, if you just feed the this feature extractor to that, like the patches are not aware of the other patches. Like, so there's no connectivity, like parameter sharing, or like there's no advantage of that. So by using the PLE, you're able to like perform an attention. And as you can see here, like we are able to improve the focus on the object. That is a focus, like focus on the object.
Okay.
That's what attention does, right? So
yeah. Makes sense.
Sure.
Interesting. Okay. Any more questions regarding the paper? I have given the permission for the participants to unmute themselves. Please shoot. Until then, I want to ask something that when you were talking about research collaboration, so I wanted to ask that your experience as research assistant, was it during your undergrad years or after it?
So yeah, I did try to do research in undergrad, but like it was difficult for me to manage like studies and to be honest, like it was not like it wasn't a very my college was very new and there was not that much push towards research. So like the proper research that I found was only when I became an RA at IIIT-Hyderabad. That's what like got it started.
So it was after your undergrad, so you took some time out to do research assistantships.
Yes, I did take some time out to do research assistant. Yeah.
That's nice. And when you talk about organizations such as ML Collective and Cohere for AI, what do you think should be like, is it more suitable for undergrad audience? And people usually lose motivation over time.
Yeah, I know. So I think ML Collective and Cohere for AI is open to all. So I even have like in the groups, I've seen people who have like worked in the industry for a lot of time and now they want to get into ML. So ML Collective has a lot of events, like they organize reading paper events. And even if you want to like get some compute or like get some advice about which path to take, so you can form some groups with people. So there's no like bar to entry, only like it depends on you. Like you have to work on like the research work yourself. And because you are with a group of people, then it's like easier to like be motivated. So that's what I felt. So yeah.
Hello. Yeah, hi. I guess I think we got disconnected. Shambhavi got disconnected. So yeah, hi. But what are your plans for your further research, and what do you think that people who are starting from B.Tech, especially in third and fourth year of B.Tech, how should they go about their research plans, and like should they do it in India? They plan to internships in like Google Summer of Code, GSOC. So what is your advice for them?
I think like anything is fine, because like even Google Summer of Code, it teaches you how to code, and like those are very essential research skills. Like if you have to work in a specific organization that even allows you to do research, so it's like not a bad thing, I think. And because it's like I think people from tier 3 colleges in India, they don't have that many opportunities. So I think whatever you get, you just grab it and like do whatever it's possible. And like there are a lot of new colleges now, and like IITs, and like new IITs are coming up, and in IIIT also there are a lot of new profs coming. So I think they all have a lot of positions, and like doing even research in India is like worth it. I think if you put the effort, you will get the output definitely.
Yeah, I'm sorry. Yeah. So, did we continue with the question, Nikhil?
Yeah, Shambhavi, I asked a question. And one more question, Anirudh, like when you're planning to prepare for this AI ML field, so how do you go about learning the topics? Like, let's say you want to learn about sound foundations in field of ML, like strong linear algebra, like strong probability skills. So how did you learn, especially coming from a coming from a college where you don't have much expertise in these fields? Like, how did you go about learning this? Did you refer online courses, or like what kind of courses have you referred in the process?
Yeah, I feel like the Coursera course by Andrew Ng is the go-to course for machine learning, I think. And I think and CS231 is also very good. So I think before getting into research, it's good to like go through them thoroughly and like do the assignments well and everything, so that you get an idea of what exactly, like the basics foundations become very clear after those courses. And in the way, like when you're reading papers, then you will have doubts. Then you can even take the linear algebra course by Dr. Gilbert Strang at MIT. And for probability also, there's a nice probability course in MIT by I forgot the name, Dr. Sipsipaz, I think. So it's right now on YouTube also. So it's completely free, and it's very it's very open to everyone. Like anyone can join with from any level. Like
because math foundations are very much needed, right? In research too, we need to understand papers with math heavy component. So we need good math skills to understand that. I think Shambhavi, Kunal, you can.
Kunal.
Your research group, you said this paper didn't came from the side of IIIT-Hyderabad, right? This is from another research group you were working with.
Yes. It's here. Yeah.
Since I'm interested in video analytics, I just wanted to know, are there other projects going around in video analytics there, and what is the scope of it, and what other projects are going around in that research group?
I don't I'm not affiliated with it anymore, so I'm not very sure like the exact projects going on. But definitely there are a lot of projects going on. It's a new university, so like they're open to people from you just have to try once. And they even have a new master's program and PhD program, and definitely like they are they attracted a lot of good people from Berkeley, Stanford.
I wanted to see, because mostly when I see video processing, basically the whole field of video processing, most papers which I see are from University of Amsterdam or certain specific regions in Europe. Basically, when I see, I think Bristol is one, UK, but I don't see a lot of papers coming all around from Asia. So I was curious, like which other research groups are working in the same field of video processing. That is why.
So like recently MBZUAI. So like we started off from Asia, if you can say, and I am definitely sure there are more works going on in video processing, because I have seen CUHK works also. And then and KAUST is also like very it's a renowned university, and they have their MS and PhD program has.
So you went there like physically, or was it like completely online?
I couldn't go there, like due to COVID restrictions. I couldn't go there, but definitely if you have a chance.
And they usually hire from India for research assistantship.
They don't mind anywhere. Like, so people from like over 75 or like countries are over there from all over the world. So they have no restriction like that. You just have to be good enough.
Just one need to write a email, or is it like you found the opportunity on Twitter or some other platforms?
So yes, I was active on Twitter, and like I'm active on LinkedIn also. So I was trying to search, and mostly like the only restriction is that for these places is that you need to have one paper already in a good conference. Like it can be WACV, it can be CVPR, like A or A-level, A-star conferences. That's like a small criteria that I have. And overall, I think the props are more or less like if they have enough funding, they'll definitely take you in. So you just have to mail, as I mentioned on the last slide.
Sure. Thank you.
Yeah, definitely.
While I do appreciate your answer, but having a paper in A or A star conference isn't a criteria.
Yeah, that
that's
definitely. Even I like, it's not a hard criteria, but if you don't have, then you can also start in India also. I mean, there's a lot of labs in India, like VAL ISC lab, which is doing very good work, and then IIT Delhi, as Nikhil mentioned, is doing excellent work. So IIIT Hyderabad is there, obviously, of course. So it's not like a hard and fast rule.
That was a lot of information gained. Do we have any more questions from anyone?
Yeah, I think Shambhavi's internet is very buggy today, so it's getting disconnected very frequently.
Yeah,
it seems to be so.
I have a question that the link of this paper is being shared. Can be shared over here, or is it shared in the
It is shared in the title itself, so you can search with the title name, so you can find it.
Okay.
I'll share the presentation also with link with the.
Yeah, if you share it, we can add it in the YouTube.
Definitely.
Sure. Thanks.
Yeah, no problem.
Yeah, I hope no other questions from the audience. Yeah, no other further questions. I think we can close the presentation. I think Shambhavi got disconnected. Yeah, thanks, Anirudh. Thanks for taking time and presenting your work. It was it was very good presentation into this area called action recognition. We hope that we will continue to meet in further publications from you in top conferences. We'd like to see exciting research from you from I think you're going for masters, right? In your masters as well.
Yes.
Yeah. Please make sure that you can mail us. We'll can schedule a talk if you have any colleagues too. Yeah. Thanks for taking time.
Sure. My pleasure.
Thanks for taking. Yeah. I think we can close the talk now.
Sure.
Thank you, guys. Thank you for attending the talk. Thank you, Anirudh. So, see you. Good night.
Good night.
Good night, all. Bye.
Thanks, Anirudh.
Yeah. Welcome.